Here we have a question on algebraic proof. So what we need to do is we need to expand both of these expressions. So we'll start off by expanding a half n plus 1. I'll use capital N, so just a little bit easier to see. So n times n is n squared, and then if you times that by a half, you get a half n squared. And n times 1 is n, and if you times that by half, you get a half n. So this first one is a half n squared plus a half n. Okay, now I'll apply the half to the second expression afterwards. So I'll deal with the n plus 1 times by n plus 2 first. We could use a grid, but I think at this level we'll use a smiley face. So we'll go n times n, which is n squared. And then we'll do the outer, which is 2n. And then we'll do the inner, which is plus n. And we'll do the last, which is plus 2. So tidying that up, we've got n squared plus 3n plus 2. Now we need to multiply through this by a half, because in the question up here, it's a half of those things. So a half, let's do it properly, write it down properly, a half of n plus 1, n plus 2 is equal to n squared over 2 plus 3n over 2 plus 1. This expansion, by the way, I was using the words first, outer, inner, last. So that's a good acronym to remember to make sure you're getting every component of the expansion. Okay, now the question says the sum, prove algebraically the sum of these two things. So that means we've got to add the two expressions together. So let's just highlight the two expressions we're adding together. We're adding this one, and we're adding this one here. We're adding those two expressions together. So let's get in the right pen. So n squared over 2 plus n squared over 2. I've written them slightly differently, which is a bit inconsistent, but they're both n squared over 2, and added together, that gives me an n squared. And then I've got a half plus 3 over 2. I've got a half plus 1.5. That's 2n. We've just got, there's no number here, but there's a 1 here. So that's plus 1. And this is the real sting in the tail of this question. You know, why is this a squared number? Well, it doesn't look like a squared number, does it? It looks like a squared number plus, well, that's a general expression for an odd number, actually. A squared number plus an odd number. Is that what we need to do? No, you've got to see that you need to factorize. Okay? You've got to factorize this. You've got to multiply for plus 1, and you've got to product for plus 1, and you've got to sum add for plus 2. What numbers are timesing for 1 and adding for 2? Well, you may realise that your brackets must be n plus 1 times by n plus 1. Because if you expand n plus 1 times n plus 1, you get n squared plus 2n plus 1. And the reason I've recognised it is 1 and 1 times 1, and they add for 2. That mantra that I was just describing. So that is a number squared. And any number squared is a square number. And I'll use the expression again. So therefore, a square number Q, E, D.